Welcome everyone. Science and Engineering World presents mathematics, more mathematics, much more mathematics. Let's go and have fun. In this presentation, I want to demonstrate how to evaluate some trigonometric ratios without a use of a calculator. My name is Olutola Fakinde. Let us consider this equilateral triangle ABC with sides 2, 2, 2 and angles 60, 60, 60. And when we have a bisector from A to BC, then we see we have two equal right angle triangles, which I'm going to pick one for today. We now have here this ABD, where AD is the bisector. So we need to find what is this bisector. And by the use of Pythagoras theorem, we can say that AD squared plus BD squared will be equal to AB squared, which is the hypotenuse. And because we're looking for AD, we can move this to this side. So we now have AD squared will be equal to AB squared minus BD squared. AB we know to be 2, that's 2 squared. BD we know to be 1, that's 1 squared. And this gives us 4 minus 1. 4 minus 1. And that will give us 3. So AD will be equal to the square root of 3. So our bisector AD is now square root of 3. Good. So now we have all the properties of the triangle, and so we want to look at an acronym SOHCAHTOA. Which means sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And with this in mind, we can now go ahead to find the trigonometric ratios. We'll use this ABD triangle to find our trigonometric ratio. And we'll start with, for example, sine 30. This is the 30. So we see sine 30 degrees will be equal to opposite 1 over 2 over hypotenuse, which is 0.5. And so we can say that sine 30 degrees is equal to 0.5. So sine 30 is 0.5. Now let's look at cos 30 degrees will be equal to adjacent over hypotenuse. Adjacent is root of 3, hypotenuse is 2, and root of 3 we know is 1.732 over 2. Therefore, we say that cos 30 degrees equals to 0 0.866. That's cos 30 degrees. Then we now go to tan. So looking for tan, tan 30 degrees is opposite over adjacent. Opposite is 1 and adjacent is root of 3. So we have root of 3, which is irrational, and so we need to rationalize this, and we do so by 1 over root of 3 multiplied by 1, and this one is going to be root of 3 over root of 3. And that will give us root of 3 over 3, because 1 times root of 3 is root of 3. Root 3 times root 3 is equal to 3, and that gives us 1.732 divided by 3. And so tan 30 degrees is equal to 0.5774. Brilliant. So we've done that with 30 degrees. So let us see 60 degrees. And we use this similar triangle here. But remember, you can see that the opposite and adjacent has switched to the other way, because we are now looking at cos 60. We are now looking at angle 60. So we can now say from here that sine 60 degrees equals to opposite over hypotenuse. Opposite is root of 3 by 2. And root of 3 we know is 1.732 over 2. So sine 60 now becomes sine of 60 is now equal to 0.866. So that is sine 60, 0.866. And then cos 60, you can see in that same vein, cos 60 degrees will be equal to, cos 60 is 1 over 2, that is 1 over 2, that is adjacent over hypotenuse, and so we can say that cos 60 degrees equals to 0.5. So cos 60 degrees is 0.5. Right, good. What about tan? Tan 60 degrees is what? Is opposite over adjacent. And opposite here is root of 3. And adjacent here is 1. So we can now say that tan 60 is root of 3 over 1, which is root 3. So tan 60 degrees equals to 1.732. So tan 60 is 1.732. Okay, good. Now let's pause and look at this by yourself. What are the sine, cosine, and tangent of 0 and 90 degrees? Okay, no problem. Let's look at it together. So in order for us to get 0 and 90 degrees, we need to do a little construction here. And the construction we are going to have is to try and bring B in that position from where it is to move towards D. So B is going to move towards D as we move this way. So in that case, BD will be reducing. So we can move that from here, there. And so we see that as B is moving towards D, 30 degrees is reducing and 60 degrees is increasing. So we can say from here that by the time B gets to D, BD is 0, hypotenuse AB will now be the same as AD. And we can see that 30 approach 0, 60 approach 90, BD is 0 because it's a point at D now. And then AB equals to AD, and that's root 3. So with this, we can find our sine, because this is for 0 here. So we can find our sine 0. Sine of 0 degrees, 0 degrees is now equal to opposite. The opposite is now BD, which is 0. That's 0 over root of 3, and that gives us 0. So sine 0 degrees equals to 0. Sine 0 degrees equals to 0. Right, we can now look at cos now. Cos 0 degrees, now this time is adjacent over hypotenuse. Adjacent and hypotenuse are on the same line now. So it's going to be root of 3 over root of 3. That gives us 1. So we can see that cos 0 degrees equals to 1. Cos 0 degrees equals to 1. Again, tan of 0, tan 0 will give us opposite over adjacent. Opposite is 0, adjacent is root of 3. And so tan 0 is 0, tan of 0 degrees equals to 0. So tan of 0 degrees equals to 0. Now, in the same vein, let's look at 90 degrees. 90 is now at this B side here. So we're going to see that, and that case is adjacent, that is 0 this time. So sine 90 degrees will be equal to root of 3 over root of 3, and that is 1. So sine 90 degrees equals to 1. Sine 90 degrees equals to 1. All right, good. So what about cos 90? Cos 90 degrees, like we have said, is adjacent over hypotenuse. Adjacent is 0 and hypotenuse is root of 3. So cos 90 is 0. Cos of 90 degrees equals to 0. Now tan 90, this time we have to look at it closely. Tan of 90 degrees equals to opposite over adjacent. Opposite is root of 3. Adjacent is 0. So when we have a 0 as denominator, it means we have so many zeros in the numerator, and that tells us that it can continue to grow and on and on. So sometimes we write it as plus or minus infinity. It goes on and on. Or sometimes it's referred to as undefined. Undefined. Okay. So we've done 0 and 90. So we now need to look at 45. In considering 45 this time around, we're going to look at a square that has sides of 1, 1, 1, 1, and then the angles are right angle, which is 90, 90. And then if we bisect diagonally this time around, bisecting diagonally, so we're going to have two right angle triangle, and so I'm going to pick one of them, and we're going to see that we have 1, 1, and the hypotenuse AC we need to find. So hypotenuse AC is equal to AC squared equals to AB squared plus BC squared. And AB we know is 1 squared. BC we know is 1 squared. And that gives us 1 plus 1 equals to 2. So AC alone will be equal to square root of 2. So we use this to now calculate for 45. For 45 degrees, we are going to have sine 45 degrees equals to opposite over hypotenuse 1 over root of 2. And 1 over root of 2, like we say, we have a rational there, we need to rationalize it. Have a 1 over root of 2 multiplied by 1, and that is root of 2 over root of 2. And that gives us root of 2 over 2. And root 2 itself is 1.4142 over 2. So sine 45 degrees will be equal to 0.7071. So sine 45 degrees is 0.7071. Again, cos 45 degrees is going to be similar because opposite and hypotenuse. So we're going to have 1 over root of 2. So from the above, we see that cos 45 degrees equals to 0.7071. That's cos 45. And lastly, let us look at tan 45. Without me demonstrating this, I think we should be able to guess what the answer is now, because it's opposite over hypotenuse. Opposite is 1, hypotenuse is 1. So cos tan 45 equals to 1. So tan 45 degrees, 45 degrees equals to 1. If you put all of these values in your calculator, you should be able to get the same answers. In summary, anytime I have to work with 0, 30, 45, 60, and 90 degrees, I just recall these figures and then I get the solutions without any calculator. If you find this video very useful, do some things for me. Number one is to, first of all, give us a thumb up by liking the video. Number two, share to others so that they can also benefit how to solve problems like this without a calculator. Number three, make comments, because there are so many methods that you can use in mathematics to arrive at the same answer. And number four, subscribe so that as soon as I post useful information like this, you'll be able to see them without any delay. And then I love this. Keep having fun, because mathematics can be fun. And lastly, keep studying.